Hey everyone, a little quick announcement before the video. Come check out the CyberQuill's Discord server. We've already got a handful of people trickling in with a wide range of skill. Got people working on autonomous drones and creating their own Lua libraries to be used in their programs. So it's definitely pretty good collaboration, pretty cool to see what people are up to. We also got announcements for just the channel itself when videos are coming out and we're just vibing. We're also talking about setting up a Minecraft server for people to get on and work on stuff together. If you want to get involved, if you want to help out, come swing by, and I hope to see you there. All right, and we're back. Hello there, everyone. I took a bit of a break over the week. I had a lot of schoolwork, and actual work was getting pretty busy, so I needed to focus on that and kind of step away for a little bit. Also took this weekend to just chill out, enjoy Father's Day, and here we are. We are back and ready to go. So last time we finished up our project, we did a whole GUI, and it was a pretty involved program with a lot going on. And now we are going to take this into the game. We're going to dive into some RedNet and turtles. Down the line, we're going to introduce monitors, advanced monitors in particular with touch input. So I know some people are interested in that, at least judging by past videos where I've made touch or mouse-based GUIs in the past. I just have a little wireless turtle with an Ender modem. Now, if you're not aware, there are two different wireless modems in the game. We have, there's two wireless modems. So we got the normal default wireless, which is like 64 blocks by default or something like that. Whereas the Ender modem has an infinite range and can go between dimensions. So definitely better to use that in all cases. So that's what I'm going to be working with. Now for the turtle, I just went ahead and did an Ender turtle, advanced Ender turtle. It'll place with the modem already attached. You'll notice I have a pickaxe on this one. We are going to be making a mining turtle. So in order to attach a pickaxe, just grab a diamond pick and put it in that top slot here. And it'll appear in its left hand. So when we have a modem on a computer, by default it will be off. And you can tell it's kind of dark here. So if I go ahead and run the command rednet.open, with this, we need to specify what side. For turtles, the modem is on its right side. So we're going to put right. And since it's in startup, I'm just going to go ahead and reboot with Control R. And now you'll see that it's red, like it's powered on. So the modem is on. It can send and receive data. For now, we are going to start by building out a little GPS system here. It might sound a little tricky, but it's actually pretty simple and straightforward. It's just 4 computers all running one command, and they all act as hosts. And you'll notice that they're positioned in a way where 2 of them are on one Y level, and 2 of them are on another Y level. In my experimenting, I've found that you'll want to have at least 4 computers, and at least one of them be different from the rest. I just did 2 just so it's symmetrical. So we'll go ahead and create this from scratch for you. I find that the best Y level to do this at is at Y level 100. Let me grab that modem again. All right, so Y level 100, that's what these uppermost computers are at. I'm just going to go ahead and build this adjacent. It definitely doesn't hurt anything to have more of them, I'm pretty sure. So I will go ahead and just place one here. And I like to put them in a square formation. Some people will do a triangle, but it's just preference. But you will want a square or a triangle, that's for certain. So I'm just going to place them like so. Or actually, probably more like this. There we go. All right, so we got our computers placed. They are 5 blocks apart in a square with 2 of them on 2 different Y levels. So I'm going to place these modems on the top Doesn't matter what side you choose, it's all preference. And now I'm just gonna use the in-game editor, go ahead and edit a startup just so that the modems will always turn on when the computer turns on. RedNet, open top, and reboot, and it's on. I'm gonna do that to all of these. Oh, right, so all of them are powered on. Now there's a command we need to run, but first we need to get the actual coordinates of these computers. So with this, the X is 27, the Y is 4. So we will just go ahead and do GPS host, and then the X27, 100, oh, my mistake, I said Y earlier, but 100 is the Y, and the Z is 4. 4. And it'll say that a channel is open and if the position, so that means it is running. So for this one, the X will be different. It's going to be 23. And actually, this one is actually 99. It's important you get it correct. Okay, so GPS host 23 100 4. This one's at Z0. Okay, so all of these are running. I'm gonna get that out of the way. So let's go down to our computer, our turtle. Where did I put it? Oh boy, I may have lost it. Oh, there it is. Now if I do GPS locate, you'll see it says the position is 49, 66, -3. So let's double check that. 49, 66, -3. That is correct. So we now have accurate in-game positions for this. Now, you might be wondering, why are we starting with a GPS system? Well, that is because the project that I'm going to start out with is an autonomous mining turtle. Now, you'll know this is working if it says a request was received. So that is definitely a good sign. Those have been up for longer. So yeah, these should all say 1. Yep, 1 received. So that's good. Now I will show you kind of what we will make this video. This turtle started at this level, dug straight down to Y level 16, and then did a little strip mine for 20 blocks and came back. It's nothing too fancy, but it's definitely a foundation. What I did though, is I made it to where the user can select the resource that they want to target, because certain resources have different Y levels that are most optimal to be found at. So in this case, iron Y16, that's what I did. So in order to create that GUI, we're going to use the same GUI we made in the last program. So it'll be a little bit of review. And I highly encourage you to pause the video here and just build it out yourself, because it's going to be the same exact concept as before. If you're not feeling it, then I will definitely go over it again. So I'm just going to call it mine. I'm going to save and exit because I do not intend to create this in-game. That is really annoying. Alright, so I'm going to go ahead and kick this off by creating our options table. And there's going to be 6 different resources. So I'll go ahead and make 6 different entries here. We will have commas. We got to make sure we have the commas. Very important. Now I'm going to go ahead and, oops. And here we're just going to do name. And then Y level. And that's what will be in each of them. So if you're wondering how I did that, in Visual Studio, you can do a multi-line edit by holding down Alt and clicking where you want to put the cursor. You can put it wherever you want. Pretty neat. So for this, I'm going to do diamonds. And then we will do coal. iron, redstone, lapis, and gold. Now, of course, there's more resources than this, but that's going to be the list for this video. Otherwise, if we went through every resource, we'd be here forever. So I got these Y values in my own research as being the most optimal. So you can go ahead and put these down, or you can do your own research and find the optimal Y level for you. There we go. -59, 0, 16. Some of them are the same, and they theoretically could be condensed into one option here, just like the coal and lapis, redstone and diamonds, but I'm not too worried about it. We need our selected, since an option will be highlighted by default when the program runs. And now we need to make our function to draw the menu. So we're going to clear the screen, set the cursor position, and print ourselves a little menu here. Auto miner setup. Beautiful. Okay, so now we need to do our loop to go through all of the different options. So for I, we'll do opt. We're going to use I pairs for options. Now we need to go through all of these. So for whichever one is selected, if I equals selected, then we're going to go ahead and print this little arrow at the option, opt.name. So remember, opt means options. Inside options, we have name. So opt.name is pointing to all of these in quotes, all of those strings. Otherwise, we're going to have nothing and end that off. Great. So now we need ourselves a little while loop for the functionality of this menu here. We created the GUI, now we're doing the logic. Creating our pull event. Now for this, we need to lower our selection by 1 when we go up on our keyboard, or with W. If it is already at the very top of the menu, then we need to go to the very bottom. So get the amount of options. Otherwise, if we're doing S or going down, we're going to increase our selected by 1. And same deal if selected is greater than the amount of options that exists, then we're going to put it back at the top. Otherwise, if the key is enter, then we're just going to simply break out of this loop and be done with it. Cool. Okay, so now we need to just go ahead and clear the screen. Set the cursor position back to the top corner. I'm going to go ahead and print to the screen the selected resource. So that's just good clarity for the user and for our debugging. So selected resource. Actually, we need to create that. We need to make a couple variables here for our selected resource. Selected resource equals options. And we're basically taking this number, whatever it is, and pulling it out of the table. Because it could be anywhere from 1 through 6. All right. And we need to get our Y level because it's very helpful to know where they're going. So target Y. There we go. So we are, if you don't, so you're understanding, the selected resource is basically taking this option here. So if we say highlight iron, then we are selected 3. So options number 3 corresponds to iron here. Now iron has 2 entries. We got the name and the Y level. So if we do selected resource dot Y level, then we are pulling this out as well, which is 16. So that's how we get the resource selected. This is how we get the Y level it will go to. Now we can print that out. Selected resource and the name. Then the target mining level. And we're just going to go ahead and do y equals target Y. Cool. Go ahead and do like a little sleep so we can see it before it takes off. So this should run. Let's go ahead and just see what happens. So if we do mine, I have a little typo. If key, oh yeah, there's only one equals there. That would do it. All right, mine. Oh, another typo. Line 33. Oh, I don't have an equal. I went too fast. There we go. So now we got our menu. I'm gonna go ahead and select iron. Target mining level is 6. Selected resource is iron. So that is working. Now for the GPS, we need to make a function to get its position, its current position that it's starting at. Let's go ahead and create a function here. I'm gonna call it descend. And then we're gonna take in target Y. Then we'll create a function strip mine and then length for how far it's gonna go. Should be good. I think that's all the functions we will need. Just up here, we're gonna do a little. We're gonna get that starting Y. So I'm just gonna declare this variable local start Y. And then what I like to do, there's a command gps.locate. And then inside of here is a timeout. It takes an integer. So if we put 2, it's going to try and locate for 2 seconds. If it doesn't get a response from the GPS servers or the anchors, those computers we built in the sky, then it's going to time out and nothing will happen. So what I like to do is instead do a for loop and have it try and attempt to connect a few times. So we'll do 5 times in this case. We're going to get our X, Y, and Z coordinates from gps.locate. And each try, it's going to try and get it for 2 seconds. So how do we know if we actually got a response? Well, we know because we will actually have, these variables will not be nil. So if Y, then, or AKA if it exists, then I'm just going to do start Y equals Y and break. And then I like to do a little sleep in between. Now, if there is no start Y after all of those attempts, then we will simply say GPS unavailable and then return. Now, what I'm going to do is say for whatever reason it loses connection to the GPS anchors, I'm just going to have this program run manually after it gets the initial Y level. Theoretically, if everything goes well, there's nothing, no gravel or anything that could hinder it, then it should be quite accurate enough. There will be instances that we can address later down the line. For now, it's going to just be very simple and straightforward. So for all intents and purposes in this video, we're going to get the coordinates first and then manually track the Y after. So descend, I'm going to go ahead and call current Y, or declare current Y equals start Y. Now we're going to do a little while loop here. Oops, that's not great. So while current Y is greater than target Y, then we are going to start moving down. So any turtle command is going to start with turtle. Now, we need to detect if there is a block below us and then break it. Otherwise, it's going to try and go down. And if there is a block in the way, it's not going to move. And that's not going to work out too well. So first things first, we need to detect down. And then turtle.dig down if it detects something. Regardless, like no matter if it detects something or not, then we are going to have the turtle move down. So if turtle.down, then we're going to do current y minus 1. The reason why, so turtle.down will make it move down. The reason why we put it inside an if statement is so that this only happens if the turtle actually moved. Because every turtle command will return a true or false, whether it ran successfully or not. So if turtle.down was false, that would mean it attempted to move, but it couldn't because something was in the way. Therefore, this will never subtract. It helps to maintain the accuracy of y, since we're not using GPS updates for every movement. Otherwise, if it couldn't move down, then we can just say can't move, or can't move down, and sleep for a second. But this should not happen because it is going to detect if something's below it and break it first. Only way this would be a problem is if it hit bedrock or something. So after it gets to the bottom, I'll just go ahead and print reached target y. Let's do current y. So it will say where it's at. Then at this point, it's down at the y level that we specified. So if we say iron, it's going to be at 16. At least it should be. So at that point, we can start strip mining. Now the strip mining is going to be pretty straightforward. I'm just going to have it dig a tunnel straight down, and it's going to break below and above it. So it's just going to be a 1 block wide tunnel and 3 block tall. So simply, we're going to do a little for loop. So for the length that we give it, it's going to do we're going to put in a while, we're going to do a while loop. So while turtle.detect do, I don't know why I put it down, turtle.dig, turtle.dig up, turtle.dig down. So that's 3 different turtle commands, pretty straightforward. This digs what's in front of it, this digs above it, and this digs below it. All right, this is a little example. All right, so here's a little example of why I did the turtle.detect in the while loop that I wanted to show you. So for this, I made a 20 block long path as indicated by the red wool and placed some blocks. Created a little example code here with the strip mine function, just without that while true or while turtle.detect function in there. So I'm just going to run it. It's going to strip mine for 20 blocks. Oh, you know what? This turtle doesn't even have a pick. All right, let's try that again. There you go. So it's moving. There you go. So it made it to the end. It went all 20 blocks. There you go. So you think it's going to make it to the end this time? Let's see. Ah, it did not make it to the end, even though it is still programmed to go 20 blocks. So the reason why gravel does exist, but it is only going to break 1 block at each time that it iterates through this for loop. Now, this is what we have in the program that we've developed. Let's just go ahead and move this again. Cool. Let's see it. So now it should make it the 20 blocks no matter what. There we go. And voila. So that is the reason I put in the while loop here. I feel like I didn't explain it well enough in the initial recording, So here we go, extra clarification, and back to the video. And we need to, of course, take into account that there could be blocks in the way. So if there are blocks, we're going to break it first. Otherwise, it's going to try and move forward, and it can't. So this is just in an effort to prevent it from breaking itself, getting stranded. So once it gets to the end of the tunnel, say it goes 20 blocks, then we'll go ahead and turn the turtle around. I'm just going to type this twice. Because every time you do turtle.turn, it's going to be a 90-degree turn. So it's going to turn left twice in order to do a full 180 turn. Or you can do right. It really doesn't matter. And then we can go ahead and have it come back. And then turtle.forward. Now it's highly unlikely there will be blocks in the way at this point, since it just cleared it out. So I don't see any reason to do this extra measure, but we could if we wanted to be extra careful, but I'm not going to. And then that's it. Maybe we can have it turn around again. Let's do that. And it'll be at the end of the tunnel where it started. So we could, of course, have it go back up as well, but I think, at least for what I made ahead of time to show you, that's all it does, is it will go down and then dig 20 blocks and then go back to the beginning of that tunnel. So let's actually call those functions once it gets this done. We're going to do descend to target Y and then strip mine. And I'm just going to give it a length of 20. We could have an option for the user to specify, and there's all sorts of things we can do, but for now, this should work just fine. So let's run mine. And I'm going to select iron. So it's going to go to Y16. Ooh. Well, that's kind of weird. Let's figure this out. Oh, you know what? Reason why is because turtles need fuel. Turtles will take coal. So I'm just going to give it a stack of coal blocks and put it in its selected inventory slot. You'll know it's selected because it has this little square, thicker square here. We're going to go in the Lua prompt. I'm going to do turtle.refuel. There we go. Now we can get the fuel level. It's 51,200 units. What that means, I believe, let's just see. We're going to move forward. Should go down by 1. Yep. So that means it can move that many blocks. Pretty nice. Okay. That was my bad. Forgot to refuel it. Let's mine iron. There it goes. All right. We're approaching the target Y. There you go. Now it is doing the strip mine function. It's going to go down 20 blocks, destroying what's above it and below it, as well as what's in front of it. Oh, it's coming back. So it is done mining. Came back and turned around. That's what he got. But that's it. So that is, we created ourselves a little GPS system that we will make more use of later. We created a basic GUI on the turtle, and we made a simple program for it to go down to the Y level and strip mine 20 blocks. So that's definitely the framework. We're going to make it more customizable and definitely a lot smarter. And we will get more in depth over the course of these upcoming videos. I hope you enjoyed, and we'll be back again very soon. Bye-bye.